Hello everyone, my name is Dan the Tutor. This is a clip from one of my weekly group tutoring sessions at the University of Delaware for Math 221. If you have any questions, please leave them in the comments below. Thank you and enjoy. Okay, for the last set of problems we have today, I want to talk about more area under a curve questions, except this time I'm going to give you the graphs themselves, because this is another way we can find area under a curve. We don't always need to do calculus. We don't always need to use integrals, right? If we know the shape using geometry, like equations of triangles, squares, semicircles, whatever, we can actually just find this area the old-fashioned way. So let's look at some examples. I have here a coordinate axis x and f of x. And let's say I have this shape right here. I have a triangle going up like this, and then that triangle starts to go down like this. I need to give you some points here. So the point where it crosses the x-axis, that point is 4. At the very end, that point is going to be positive 6. I then need to give you the y values. The y value down here, like the tip of the triangle, has a height of negative 4 for f of x, and the tip of this triangle has a height of positive 6. Now what I want to ask you to do is, if this is f of x, I want you, without any function, to find the integral from 0 to 6 of f of x dx. So hopefully you see what's going on here. When I ask for an integral of the function, and I don't give you a function, integral just means area under the curve. So if I add the region of these two triangles, then we're good. Okay, so the first one, the big triangle that has it's an equation 1/2 base times height, so 1/2 times the base is 4 times a height of 6. Hopefully we all see that. So that's going to be 1/2 times 4 times 6, which is 12. Great. And now for the triangle down here, it's going to again be 1/2 base times height. A base of 6 minus 4 is 2, and then the height is negative 4. Notice here, the area for this triangle will be negative. It will be negative, and that's important. So the 2's cancel. We'll get a final area of negative 4. So in other words, my integral from 0 to 6 f of x dx is literally just the area between these two triangles. 12 minus 4, final answer 8. No calculus, or at least no real calculus involved. Any questions? Yeah, so this was probably the most friendly problem we had all night, right? Yeah. Well, don't worry, it gets worse. Here's the last problem I have for you guys, and then we'll wrap up early today because there's not too much more to talk about. I think this is it, honestly, for like at least the next week. So I have another set of coordinate axes here, x and f of x, just like this. I have the following shape. I'm going to draw it. Okay, it looks like this. Now, instead of giving you the x values where stuff is happening, I'm just going to give you the coordinate points. Over here, all the way on the left, is the point 0, 2. At this elbow right here, that's the point 3, 2. Down here, at that point, that's the point 5, negative 2. And then at the very end, I'm going to give you the point 7, negative 2. Now, for this one, I'm not going to ask for the integral. I'm going to ask specifically for the area under the curve. Now, what's the difference? That's a great question. So technically, it's a different question. Why? Because integrals can be positive or negative. Integrals can be positive for some parts, negative for the others. The proof's in the pudding for the last problem. It was a positive triangle and a negative triangle. But if I ask you for what's the area under the curve, that's a different question. The area, I'm going to put this in parentheses, area must all be positive. They do not need to tell you that. This is just the definition of area under the curve. Area must always be positive if they ask specifically for the area under the curve. Is it confusing? Yes, I know. I apologize. I did not make these rules, clearly. But if I wanted to find the area under the curve now, it's just going to be the shape of these two, shapes right here, and it's all going to be positive. Okay, so I can split this up, notice, into a rectangle and a triangle over here, and then another rectangle and a triangle over here. So as long as we can find these shapes, we're good. So first I'll shade in this rectangle in blue. The blue rectangle has a width or length or whatever of 3 times a height of 2, because that's how high it is. So we have an area of 6 for the blue. Then I'll say this triangle in red. Notice here, I don't know how long this is, do I? Like, I don't have this point where they intersect. I did that on purpose because I want to see if you guys can find it on your own. I'm going to give you 30 seconds to think about how we can find either the x-coordinate where this graph intersects, or just in general the length of this triangle, and by extension the length of this triangle. So I'll give you 30 seconds to think about that. If you can't get it, it's no big deal. Go ahead and go. Okay, and time's up. Put down your pencils. So, or don't, because you're about to pick them up again, because we're going to be writing. So for the red triangle, and just in general, what we need to figure out is we need to figure out the slope of this line. We need to figure out the slope of that line. The slope is equal to the rise over the run, right? I see that I'm going down 4, 1, 2, 3, 4 to get from positive 2 to negative 2. So the rise is negative 4. The run, I'm going from x equals 3 to x equals 5, so the run is 2. In other words, my slope is negative 2. And here's why that's important. I'm going down 2 every x point. So if I start at positive 2 and I go 1 to the right, I'm now at 2 minus 2. I'm at the 0 point. What I'm trying to get at here, the point is x equals 4. It's x equals 4. Then we go down another x point. We go down another 2. That confirms that, yes, it is 4. And again, I did that by finding the slope. Now, if this method is confusing to you, I know I didn't explain this the best that I could have. I don't think it's the biggest deal in the world if you don't understand it. But just try and listen to this explanation again later tonight or tomorrow. Watch the YouTube video. Give me a like and a subscribe while you're at it. Thank you. Now, why is this important? Because now I can find the area of the red. The area of the red is going to be a base from x equals 3 to x equals 4. That base is 1. Oh yeah, and it's 1/2 out in front. 1/2 base times height. So 1/2 times a base of 1 times a height of 2. The area of the red is just 1. So now I have 2 areas. I have 1, I have 6. Now I just need to find the area of these last 2 shapes. I'll say this triangle in green. Next, I am running out of room. Let me clear some space for myself. There we go. Okay. So for the green, notice I have 1/2 base times height. The base is from x equals 4 to x equals 5, which is a base of 1, times a height of negative 2. But again, I asked for area under the curve, which means they want me to give all positive numbers. So again, this is going to equal positive 1 because the 1/2 and the 2 cancels. Now we just need to finally find the area of this last, let's say, yellow rectangle right here. And that rectangle has a base of from x equals 5 to x equals 7, which is a base of 2, times a height of negative 2, which I don't care about the negative, so just keep it positive. We'll get a final area of 4. Now, my final answer to this question, I just need to add all the areas together, keep them positive. It's going to be 6 plus 1 plus 1 plus 4. Final answer for the area is 12. Okay, thank you all for sticking around. This is it. Don't forget to like and subscribe. If you want me to start doing free weekly group sessions at your university, please post in the comments below or email me at dan@danthetutor.com. Thanks everyone. Bye-bye.